So a change of pace here. We're looking at the inequality in one triangle. So all this is the relationship between sides and angles. The largest side or largest angle is always across the longest side, or the longest side's across the largest angle. Same thing with the smallest angle and the shortest side. Those are always across one another. For some reason, the hardest thing for some students is just to know where it is across. Okay? Got to go all the way across to the opposite side. Always. All right, so let's look at this one here. So what we can say here is if we can compare sides, then we could easily compare the angles because of this relationship. So here we can say that 9 is greater than 7, right? Can we say 9 is greater than 7? Okay, then the angle across 9, which is Z, should be bigger than the angle across 7, which is X. So if 9 is greater than 7, then angle Z should be greater than angle X. All right, and then same thing if I was to go in reverse, the converse of it would just be the opposite. So if angle 110 is greater than 45, then the side across the 110, which is L to K, should be greater than what side? J to L. Okay, let's look at the first example. It says list the angles of triangle PQR in order from smallest to largest. So in order to get the smallest angle, you're going to go to the smallest side. What's our smallest side here? 7.5. So the smallest side is 7.5. So the angle across from it is angle Q. That is your smallest angle because they're telling you to list the angles. So angle Q is your smallest. Then what would be the next side in order from smallest to largest? The 8.8, so it would be angle R. So then the largest angle would be angle P. All right. The next one is just asking you to go backward. So here we're going from largest to smallest. So our largest angle is what? 121. So what's the largest side then? Because we're looking for sides. The side from R to T, followed by what side? What would be the next angle from largest to smallest? R to S would be the next side. So then the largest, or smallest side, sorry, the smallest side would be S to T. Good. All right. So that's pretty much straightforward what it is, the angles and the sides being related to one another within one triangle. But looking at just this triangle, the only thing we're asking you to do is just to find the missing angle, right? Which we've already practiced this. We can say 180 with the difference of 90 and 32, or we can say the difference of 90 and just 32, right? Because reminder that these two have to add up to 90 anytime we have a right triangle. What would the missing angle be? Would be 58, right? 90 minus 32 would give us 58. And then once we have this, now we can list the sides. So, all right, so from smallest to largest, what would be your smallest side? J to K or K to J, either one would be correct. What would be the next side from smallest to largest? What would be the next number? From smallest to largest, would the next one be 58 or 90? 58, all right, so we're gonna go across to this side. This would be J to L. So then the longest side would have to be K to L. Why else should K to L be the longest side? Because it's across the 90. What's this called on the right triangle? The hypotenuse, thank you. The hypotenuse. The hypotenuse is always the longest, always, on a right triangle. All right, and again, so we gave y'all the basics. Now we're going to use it, and we're just going to do calculations for it. So again, what did we say about these two angles? These two angles have to do what? They have to add up to 90. So we could just say that x plus 15 plus x plus 10 has to equal 90. Let me know what you get for x. Let me know what you get for your x value. What'd you get, Jaden? What is it? Or the x? 37.5? What'd you get? 32.5? 32? Okay, 32.5. It's okay. Don't look nervous, guys. 32.5. It's okay if it's a decimal. All right, so then once we have this, you have to plug it in to get the accurate angles here. So 32.5 plus 10 would give us what for this degree? 42.5 degrees. That's the degree of angle L. And then here, 32.5 plus 15 would give us what? 47.5 degrees for angle K. Good. All right, so now we're going to list the sides in order from smallest to largest. So what's your smallest side here? 42.5. So then the smallest side would be K to J, followed by J to L, because the largest side has to be your hypotenuse. All right, when you're ready, we'll go to the back side. Let me go ahead and have you guys try these three real quick. So if y'all can try A, B, and C real quick. A, B, and then C down here, the word problem. Looking at the first one, it says list the angles of triangle ABC in order from smallest to largest. Cole, what was your smallest angle, Cole? You look for your smallest side. What's our smallest side? 3.7, good. So you're gonna go to the opposite corner. That's gonna be your smallest angle. So what would be our smallest angle? Angle what, Cole? You're just telling me the letter right there. Angle B, good. All right, what would be the next number in order from smallest to largest? Would it be 4.8 or would it be 7? 4.8, good. Go opposite angle. What would be our next angle? Angle C, so then your largest angle is angle A. All right. All right, looking at X. What did y'all get for y'all's X value? 5.6? Yeah, okay. X is 5.6. How did y'all get that? Y'all had to do what to all the angles? Add them all up and set it equal to? 180. Good. All right, so then after we plugged in 5.6, what was your angle for M? 38.4? Sorry, 78.4. 78.4. All right, what was your measurement for angle N? 40.4? Okay, just trying to make sure I'm hearing you all right. And then the last one, what would be the measurement of the last one? 61. Thank you. If I don't say okay, if I don't repeat it, guys, because I didn't hear you the first time. All right, so we're listing the sides in order from shortest to longest. Noah, list me the sides in order from shortest to longest. List me the sides in order from shortest to longest. So if this is your smallest angle, what's your shortest side? M to L, followed by L to M. Oh wait, what was the next one? From smallest to largest, should it be L to N? It should be N to M. Yeah, because 61 would be next in line. So it would be N to M. And then the largest one would be L to N. All right, so just be careful as you guys are working on that assignment. All right, on C, it says, during a lifeguard training, an instructor simulates a person in distress so that the trainee can practice their rescue skills. If the instructor, trainee 1 and trainee 2, are located in the positions shown on the diagram, which of the two trainees is closest to the instructor? Be careful with this one. What did y'all have to do first? You can't compare the sides unless you know all your angles. So we have to figure out the missing angle. Yes, add them together, subtract it from 180. What do we get? 61. So this is 61. All right. What did who was closest to the trainer? Which one? Should be trainee 2. Yes. So this is your smallest angle. So this is your shortest side. So then who's closest to the instructor? A lot of you said trainee 2. Who's the closest to the instructor then? It should be trainee. It should be trainee 1 because that's the shortest side. Remember, the smallest angle is across the shortest side. And I know this picture, I know it looks like an equilateral triangle. You need to go off of your angles. So a lot of students on this one will pick trainee 2 because they see the smallest angle and automatically they're going to go with that. So trainee 1 is the closest one. So if you notice, what I did is I identified the smallest angle and identified the shortest side before I started looking to see who it was. So this one should have been trainee 1. All right, who remembers the exterior angle theorem? Because we're going to get to that here in a minute. All right, on the homework, you're going to have this here. So this is what you're going to do. Remember those crazy puzzles I gave y'all that a lot of you guys didn't like? We got to get to those puzzles again, okay? All right, so let's see. You're going to find, I would find everything in here if you could. So how could I find angle 1 and angle 2? What do we know about triangle ABD? What do we know about angle 1 and angle 2? They're equal. These two angles are equal. We also can see that this makes a triangle, and every triangle has to add up to how much? 180. All right, let me know what you'll get for angle 1 and angle 2. So figure it out for me. 62. All right, so this is 62. Does everyone agree 62 is the right number? Before I write it down? Okay. 62 and 62. Anything else I can figure out? How can we figure out the other two angles in the other triangle? $62 and do what with them? Add it to 23, but okay, 62 plus 23. That's one way to do it. So what's 62 plus 23? The whole thing here is 85. All right. So if we're going this route, what else could we do? Add 56 and 85, and then subtract it from 180. All right, so add those for me. And then subtract it from 180. What do y'all get? What'd y'all get for y'all's angle? 39? All right, so this angle is 39. And then what do y'all want to do with the 39? How can I figure out that angle next to the 62? You could do one of two things. You could add these two angles and subtract it from 180. Or, and this is the direction I thought y'all were going to go initially, these two angles should add up to what? 180. A lot of students still forget that. Remember, those linear pairs, those supplementary angles are there. So what's the difference of 180 and 162? 118. All right, so then once you have everything, so this is what I recommend you do. Figure out all your angles there. Let me fix this real quick. I don't know why we have a B and a C here. I think I have a picture over a picture there. Okay. All you're going to do is you're going to look at the angle across side A to D. So look, they're looking at A to D and B to D. What triangle are they focusing on? ABD or DBC? Which one are they focusing on if they're comparing A to D and B to D? A to D. All right, so they're looking at the highlighted purple one. So looking at the highlighted purple triangle, what degrees is across A to D? So I want you to write 62 degrees right there. All right, then go to B to D. Go to B to D, and we're going to go across this side. So across this side, I have what angle? 56. And once you have that, just compare your numbers. Which one's bigger, 56 or 62? 62. So A to D has to be greater than B to D. All right, look at the next one. It's BD and BC. So they're looking at the, if you're unsure what triangle you're looking at, look at the three different letters, B, D, and C. So they're looking at this triangle down here at the bottom, the one that's filled in. All right, so looking at the one at the bottom, what degrees is across B to D? 39. So across this side is 39. So I'm going to write 39 here. What angle is across B to C? 118. Which one's bigger? B to C. Okay. So let's try this one. With this one, all the numbers are given. And those of us that struggle with angles, this is what's going to get you. So you got to be able to read your angles. So if we don't know how to read our angles, trace your letters. I want you to trace A, C to D. So let's all trace A, C to D. A, C to D. And that's it. You stop there. A, C to D. Is the angle at the A, at the C, or at the D? It's at the C. What number is across the C? 4. So across this one, we have 4. All right. Do the same thing with the next angle. You're going to trace D, A to C. Where's the angle at? At A. It's always the middle letter. So what number is across A? 6. All right. Which one's bigger, the 4 or the 6? The 6. All right. So I'm drawing my inequality real big just so I don't confuse it with an angle. All right. Go ahead and try the next one. Next one's looking at triangle CDE. CDE. All right. All right, so looking at triangle CDE, what number or what side length is across CD to E? 4, should be 4. And what side length is across DC to E? Should be 3. So which one's bigger? The 4, right? And again, I would just draw your inequality real big. All right, to finish up the exterior angle theorem, remember we said that the two non-adjacent angles, 1 and 3, are equal to the exterior angle. All right, and that's what was in our last chapter. So this one says, find the side length with the greatest measurement if SUT is 3x minus 1, STU is 83, and JST is 12 plus 10x. So I'm going to write everything where it should go. So here I have 12 plus 10x. At the T I have 83, and I'm just kind of looking at that middle letter. And then at the U, we have 3x minus 1. All right, so how do I set this up using that exterior angle theorem? Okay, 83 plus 3x minus 1 equals 12 plus 10x. All right, let me know what you get for x. So you read that last part, it says give your measurements used to prove your answer. So make sure you show work on these. What did you get for your x value? Should be 10. All right, so what's 3 times 10 is 30, minus 1 gives us 29. 10 times 10 is 100. 100 plus 12 is 112. All right, so it says find the side length with the greatest measurement. So if this is 29 and this is 112, you got to figure out this angle right here. So if this is 112, what should this one be? 68. Do you agree that's 68? Yeah? Okay, 68. All right, so the largest side is across which degrees? 83, good. So 83 is our largest angle. Across that is the longest side. So our longest side is S to U. All right, I'm gonna let you guys try the next one. Do the next one the same way. What'd you get for the x value? 12. And for angle C, what did y'all get? What was that? 110. And for angle BAQ, this one on the exterior angle? 140. So what's the angle on the inside? Should be 40, yes. I was writing 40. All right, so then this one's looking for the side length with the greatest measurement. So what side should it be? This one should be B to A.